Hi everybody, so I've got an LS-Dyna slash ls-prepost tutorial I'm working up right here. This is what we're going for today. I'm going to create this and kind of go through the steps. We have a block that's going to be like a foam or like a rubber that we're going to compress with a really hard sphere or ball, kind of like just like a metal ball. I won't call it steel because it's not going to be steel, it's just going to be really hard. And then on the bottom, we're going to have a rigid plate, which is going to act as the ground, so it's not going to be able to move in any directions. And I wanted to create this simulation to kind of get into some more variables that people may need to know about simulations, like different types of contacts, how the sliding of this block along the rigid plate is going to affect the element quality of the block and different parameters of the block and the impactor, and how different constraints can cause different results in simulations. So a lot of times you have constraint-based simulations where the edges are programmed to basically stay in line with each other and move outward. And I may get into that as well, but this may be split up over multiple videos because it's probably gonna be gigantic. I know a lot of people want to see how everything is made, so I'm going to do that first. And if this video is long, I'll be putting a jump link right here somewhere so that you can jump ahead if you don't really care about that and you just want to get into the other stuff. But this is what we're going for, and I'm going to get into how we can set this up. So if you open Prepost, you have your blank window. If your window doesn't look like this and it doesn't look as intuitive, where you have the text below it, I've got a video I'll link below that shows you how to do that. But we want to first set up this simulation. So we'll go to element tool. Actually, that's not true. We'll go to mesh and we'll go to shape mesh. Prepost is not great for meshing things like geometries, but it's good for meshing really basic shapes like blocks, cylinders, spheres, any of that type of stuff. So it's fine doing this. So what we're going to do is we're going to first mesh our block, so like the elastic block. So you're going to click this down box, go to box solid, because we want it to be a solid, we don't want a shell. And then click by region. So these two, Pmin and Pmax, this is basically like, if you think of a block, maybe I'll just make it first and then I'll explain it. We want it to be 100 millimeters by 100 millimeters by 100 millimeters. It's not a huge deal. Maybe I'll make this, now let's just do a box. So this is the distance from the points. So our first point is going to be at the origin, so 0, 0, 0. And the last point, so like the furthest from that point, and I'll show you what I'm talking about, is going to be 100 millimeters away in the X, 100 in the Y, and 100 in the Z. So it's going to be a perfect cube. And then here is the number of elements along the edge for the X, Y, and Z. You can do this by number, or you can also click here and determine the size of the elements. So you can, if you want the, so if I make this 100, or if I make this 10, there's going to be 10 elements along a 100 millimeter long edge. So each of the elements is going to be 10 millimeters long. So making the number 10 and making the size 10, ironically, is going to be the same thing, because it's going to be 10 elements here, and here you're actually defining the same thing. But we'll just leave it at 10, 10, 10. So we're going to have 10 millimeter long elements to start, and you can make a target name. So let's call this, let's just call it block. And you can name your target part. We can just leave it 1. It doesn't matter. Create. So if we accept this, we look out. This is actually pretty coarse. You know what? I'm actually going to make this a little finer so that it's easier to, like, it looks better in the initial simulation. Maybe I'll do some increase in mesh later in the process, but this is a good test. So if you want to delete something that you made and you've already hit accept, there's no like reject now, it's already done. So what you're gonna have to do is hit done, go to element tool. There's multiple ways you can do this. This is one of them. You can go to element edit, and then up here click delete. And you can normally keep this on remove new unreferenced nodes. And what this is saying is if you delete the elements, if this option is selected and those nodes that are attached to the element aren't referenced by anything else in the model, it's going to remove them. if you click this and you delete the elements, those nodes that make up the element are going to still be there. So we'll just leave it here. You can do it on the, you can come down to this selection box. We'll just click by part. So it's going to select all the elements by the part that you click. And if you click it, then you go here and hit delete and then accept, and it's going to be gone. Now, if you go to model and then go to keyword, and then you still see there's a part here. So it actually didn't delete the part, interestingly enough. So you have to go in here and hit delete as well. And there's another way to do this. You can actually go into part ID, and then from here click the part, and then it should pop up somewhere here. Oh, here, delete, and then it'll just delete everything. Just force of habit. I always just do this, but so let me just remesh this. I'm actually make it 200 wide. Yeah, sure. And then I'll make these 20. Is that going to be the exact same thing? It may be the exact same thing, but it's just bigger. So, sure. So that looks a little better. I don't know what just happened. All right, so our block is 200 by 200 by 200. So now let's make the impactor. So go to shape mesher again, click here, go to sphere solid. You can do either shell or solid here, but I'm just gonna make it as complicated as possible and go to solid. So we know this thing is 200 by 200. So let's make the sphere, let's make it 50. So this is the radius. Actually, 50 is going to make it 100 wide. So let's do 25. The density is the density of the elements. I'm not sure what is actually going on when you do that, but I usually just try it, and if it looks right, I'll hit accept, and if it doesn't, I hit reject. Let's go with ball. And then it's going to automatically change the starting node ID and the element ID based on what's available. So we hit accept, and it's down here. And it looks like it's going to be a little too coarse, I think. So you can hit reject. Go up here, density. Let's make it 10. Accept. That looks better. Okay, so you can hit done. So it created the sphere at the origin, which is here. So our first point, oh, I never even went over that. The block mesh, this first point is 0, 0, 0 that we made, which was down here. And then the second point, P max, is this point way up here. So it's like the opposite point. And that's how it's making the box. Sorry about that. But whenever you make a sphere, it's going to create it at the origin unless you specify it otherwise. But we want this ball up here because it's going to be impacting downward. And we're going to go ahead and make, well, actually, it makes more sense to make Z upwards. So let's bring the ball up here. So in order to change the position of the ball, you can go to Element Tool, Transform. Let's go to Translate, and then we're going to move it in the Z first, and then click by part. And this is actually going to move the nodes, and you can click the ball. If you hit by part, it's going to select all the nodes. And so if we want it up here, we know this is 200 millimeters tall, so we can just start with 200 and then hit Translation Plus. So now it's up here, and we know the ball is 25 radius, so we can say 30. That looks good. Now we need to move it in the Y and in the X, so we change this to X. Let's go 100 because it's half. Yeah, that looks right. And then Y. All right, now the ball's in the correct position. So now we need to make the last part, which is the ground or the rigid plate. So let's go to Mesh, Shape Mesh, 4-node shell. So there's a few ways you can do this. You can specify, so if you highlight this, is say enter XYZ for point 1. You can actually like enter like an arbitrary point in space for this. But I'm basic, so I'm just going to click the nodes at the base of this box like this. and it's going to create it here. And we can say number of elements along X. So let's just say, what was this? 20? Let's just say 20. Let's do the same. Actually, you know what? Let's do 40. Let's do double because we're going to scale this out to be twice the size. And this will be called, just called ground. It's fine. It's fine. All right, so it's double the density, which makes sense because we just did that. And then let's also move the block up 1 millimeter because we're going to make this bottom plate 1 millimeter thick. So let's, actually I can make it 0.5 up. So let's just move it off. So we're going to move this block in the Z direction 0.5. It'll make sense later. So while I'm doing this, I'm getting it off of the plate because these two things are going to have a contact with each other. And I'm going to end up making this bottom plate 1 millimeter thick. And it's going to extrude the thickness in both directions. So 1 millimeter thick is going to be 0.5 and then 0.5. So if we move the block up 0.5, it's going to remove any initial intersections between the block and the plate, but it's going to be close enough so it's not going to be any movement when we simulate it. So that's good, except, and now we're going to go back to transform, go to scale, and then we're going to scale this plate in the Y and X direction by 2 because we just want to make it bigger so that the box can expand without falling off the edge, like the edge of the world. Any flat earthers out there? Okay. So you click by part again, you can click this, and then you click pick origin, which is just going to pick the center of scale, and this doesn't have to be scientific, honestly, in this case. You just click a point. And then go here to scale plus, and oh, I did not do that right, so reject. You want to make sure your scale direction is in X and Y, and then do it again. There you go. So, and what that'll do too is it actually makes these elements about the same size as these elements. All right, so now we have it all set, the mesh at least. Now we need to assign some material properties to these different parts. So if you go to model, keyword, you can go straight to part. And then from here, we got our block, which is here, ball here, ground here. So we'll first give the ground some material properties because it's a shell, so it's different, and it's going to be the easiest material because we're going to make it rigid. So in order to make, or to give this part a section ID, you just click this button, new keyword, and it's going to automatically, it's going to like collapse this for some reason, and you just got to drag it open. But it's going to automatically make a section shell for you here, which is what this needs because it's a shell. Just give it a section ID. I usually stick with whatever the part ID is, so it's part ID 3, so I'll just say this is section ID 3. You can leave the element formulation to 2, it's fine, it's rigid, doesn't matter. And then here we're going to make the thickness 1, and this is what I was mentioning, the thickness of the ground, we're making it 1. And inlock is where you set whether the thickness is extruded from the center line or top surface or bottom surface. So inlock of 0 is mid surface where it's going in both directions, and then you can actually do it so it moves in one way or the other, but I suggest against that a lot of times because it can cause issues later down the line, especially in more complicated setups. So let's accept this, and so now you have your section ID. Every time you accept though from that other window, you have to accept it here too. And I'll show you why, because if you click off the ball and you go back to ground, it's not there anymore. It still made it so you can click this button and you can actually go here and select it, but it didn't save it as part of this part. So you hit accept and now it's saved in there. All right, so let's give it a material property as well. So go here, click this, get a new keyword, and we're gonna make this rigid. So it's 20, here it is. You just double click it. And let's give it a material ID of 3 as well. Density, I think we're going to give it something similar to steel. So I am in the units millimeters, kilograms, millimeters, kilograms, milliseconds. I'll write it up here, the unit system that I'm in. And I believe this is the density of something like steel. Whenever you make a matte rigid part, you want to give it material properties of something that's similar to what you're going for. It may be rigid, but if you give it a density of like cotton, it's not gonna like it. It's just LS-Dyna is gonna get mad. So just give it something similar to what you're going for. And I'm just going for like a steel plate or something. It's an elastic modulus. I just give it, I think it's 8 or 40, something like that. Poisson ratio. Yeah, see, reasonable values have to be chosen. Okay, so that's that. You can look up any of these if you want for like something stiff. It doesn't matter. CMO is important here. So this center of mass constraint option, in usual Dyna fashion, this doesn't make any sense. So all this is doing is applying a constraint to this part. Because it's matte rigid, you can actually apply global constraints to the parts. So we're going to apply a constraint so that this plate can't move at all. And you do that here. You can give it 1, so the constraints are applied in global directions. If you have a local coordinate system, you can say -1, but we don't, so we're going to say 1. And then here, constraint 1, this is the displacement constraint. So if you make this, let me move this. So if you make this 1, this plate will not be able to move in the x direction. It will still be able to move in the y and the z direction, but not in the x. We want this plate to not move in space at all, which is 7. So the numbers that you put in here are these numbers, and they define what's going to happen with the parts. So we want this to be constrained in space, so we're going to make it 7. Constraint 2 is rotation. So it's the same thing, but rotation. If we left this here and hit like this plate on the edge over here, it may move, or there may be some noise in the simulation depending on what's happening. And like, it's just, if you want it to stay in space, you want to do both. So 7 and 7. Isn't that a drink? I think that's a drink. So then we hit accept, and then you want to hit accept again. And so we have the plate done. So we're going to go and do the ball now. Sure. So we'll go to section ID, click this. And then you can't click this section because this is for a shell. So what you have to do is new keyword, and then it's going to make a new section solid because it's a solid, not a shell. And we're going to make this, I think we're in 1, I believe. No, the ball is 2. And then element formulation of 1 is fine. Usually when you use solid elements, this is what you're always going to use, just because solids are way more finicky. But you can use this. Accept. Then we're going to make a material ID. Let me go ahead and accept this. So material ID, we're going to give this just a really stiff elastic property because it's really not meant to do anything. What we're going to be analyzing is the block, not the ball. The ball is going to be there just to apply some force to the block, and the base is going to be there just to apply or just to resist the force or keep the block from moving downward. We could actually give this a rigid material if we wanted to. I'm just going to be complicated and give it something else. So whenever you click new material, you go here and you can double click elastic. Material ID 2. Density, we're going to give it something similar to steel. And if this is wrong, I'm embarrassed. But Young's modulus, let's say 40. Poisson's ratio 0.45. And there we go. So now we have a rigid plate acting as the ground. We have a semi-rigid ball. It's just really stiff. And now we need to do the block. So again, you can go to section ID here, click this button, and now you can actually reuse sections if they have the correct properties. And if they're solids, they're usually going to be the same. So I know that we just made this section for the ball, and we can reuse it here. So you can actually call section IDs multiple times. You can do that in materials too. So we're going to hit accept, and then we're going to go to material, click here, and we're going to do new keyword, And for now, we're going to do elastic. I may do some other ones later. Let's do new, make this one, to test out other materials and how they respond or something like that. Who knows? So density, let's just call it 1, E-6 water is fine. Elastic modulus, we're going to make this really soft so we can see like a lot of deformation. That may be too much, but I can mess with it. And Poisson's ratio, sure. So, accept. So now we have all of our parts meshed, and they all are somewhat realistic. So if you go to select part and you see all your parts, you can, if they're activated, you can hit info and then click here, and it'll tell you the details of each of the parts. And if they're all activated, you can actually click through, and it's a quick way to check that all your stuff's in there and looks right. So, yep. So now the last step is to set up the boundary conditions, which is the ball, the motion of the ball downward, and the contacts between the ball, the box, and the plate. So we'll define the boundary conditions for the ball. You can go to keyword. Usually there's two ways you can do this. You can go to boundary and then prescribe motion. Prescribe motion set. And what you have to first do is make a node set of the ball, and then you give it a degrees of freedom and a velocity, displacement, whatnot. And this is fine if you, what's the best way to say this? This is fine if you want the ball to move at a defined rate permanently. Like if you use boundary prescribed motion, it's going to do what you tell it to do. So the block won't be able to resist at all. So if you tell the ball to move at 3 meters per second, it's going to continue to move at 3 meters per second, even if the box is, or the block is resisting it. So for anyone who's trying to figure out how to do it, this is, it's a fine way under certain circumstances, like a compression test for like a MTS machine or something like that. But for a case like this, it's a little, it's not right. So don't use this for a situation where you're just trying to like throw something at an object, unless you know what you're doing. But for this case, we're going to use something called initial velocity. So go here to initial, and then go down to velocity, and we can just do initial velocity. And we're going to need a node set again. So for a lot of these, you need node sets. We're going to have to make one before we do this. But basically, initial velocity, we're going to give it a velocity in one of the directions. So in the Z direction here. So if we go to create entity up here within the model tab, and you go to set data down here, and then set node. If you click through all these, you'll be able to see what you have, but right now we don't have any sets. So you go to set node, and then to create. And I have videos on how to like modify different things and make different sets in different unique ways, and you can find those on the channel if you want. But for now, we're going to go to set node, create, and we're going to go by part, and just click the ball and then hit apply. And you can call this, you can usually call it something like ball just so you can keep track. Hit apply. So then you have the node set of the ball, hit done, and then it's going to stay active. So if you don't want this to continue to be highlighted, you can go to display and then go into set node, and then you can click none, and it won't be displayed anymore. You don't have to, but it's just advice. So we go back to initial and then to velocity, and then your node set, you're going to click this button, which is always like the selection button, and then go to ball, and then you can hit done. And what we want is a downward Z velocity, so it's going to have to be negative. And I don't know if this is going to be right or not. I may change this, but for now, let's just say we're going to be in meters per second because it's millimeters and milliseconds, which is the same as meters and seconds in terms of velocity. So let's just call it negative 10 meters per second. We'll see. That may be too much, maybe too little. I'm not sure. But we'll leave it like that for now and see how it does. This is part of the biggest aspects of modeling is a lot of it's just trial and error. You just try it, see what it looks like, especially in something that's very arbitrary like this. We're just trying to mess with things. And that's it. Then you hit accept and then done. And now if you go display and you go to initial, so now you have initial here, and you click velocity, you can click it and you'll actually be able to visualize that all of these nodes are pointing downward and they're all facing the correct direction, so it's all good. There's also initial velocity rigid part. If you had a rigid ball, you could actually just assign it to the entire ball, but we don't have that. So now onto contacts. So we're going to have a contact between the cube and the plate, and then the ball and the cube. So let's do keyword, and then minimize this, all this stuff's open. Go to contact, and your most commonly used just normal contacts are going to be automatic single surface and automatic surface to surface. So automatic single surface will be a single contact with a bunch of part sets. So within a contact, you have your slave over here and your master over here. What this is like two different entities impacting each other, right? Within a single surface, you're only gonna have to define the slave side because it's a contact between everything that's included, and you're always going to use a part set. So if you go here and you go down to 2 part set, you're going to want to make all these into 1 part set, and then you can call it here. There's also a ton of options down here, which we may go through and change them as we go to see how it affects stuff. But for now, just know that if you use single surface, it's the most easy to set up. It's also the least computationally expensive, but it's not the most accurate. So with that in mind, I'm not going to use this in this case, at least for now. I'm going to use, you can ignore, I'm going to use contact automatic surface to surface, and I'm going to make 2 contacts, one between the top of the cube and the ball, and the bottom of the cube and this plate. So we're going to make 2. So automatic surface to surface here, and you can just double click it. And so let's do a segment set between this top surface and a segment set of the ball. You can actually just do the part of the ball, but we first have to make these sets, so I have to make them. So yeah, so we're going to create entity, set data, set segment, create, and then we just want to segment along this top surface of the cube. So what you can do is go to by element, go to propagate, which is here, and then you can just click this top surface and it's going to select just the top, and then you can hit apply, and then there you go. It's actually pretty important to name these as you go, because you're not going to be able to visualize them when you select them in that keyword menu. So if you want to modify something, you have to go to show, and then it has to be clicked, so it has to be blue, and then you can go to mod, and then you click it here, so then you can see, and you can like deselect stuff and reselect it. You can change stuff. You can also give it a name, so let's call this cube, why do I keep calling it cube? Block top, and apply. And then we also want to make one on the bottom, so I'm gonna need to deselect this for now. So create 2. Let's call this block bottom, and then we're gonna use the same way, propagation. Click this, apply, perfect. And then I'm gonna make another segment set of the plate at the bottom. So general rule of thumb, you can use segment sets or parts or part sets in contacts. There's other things you can use, but for now we're gonna look at those 3. Segment sets are generally the most accurate because it's actually going to like bake in what is going to be in contact with other things. And order matters, and like between like what's slave and what's master, but for now just know that segment set's going to be more accurate than parts. And then parts are just easier to set up though, but if you have things that are sliding on each other, like this plate and the bottom of the cube, I'm going to make them both segments. It's going to be a segment set to a segment set contact. So I'm going to make another segment set here. So I'm going to call this plate, and then okay, and then apply. All right, and then the ball, I'll do the same thing, just to be consistent. And then you may need to mess with the propagate stuff, because this is where it's a little tricky to select just the surface of the ball. If you go to by part, which you may think is right, it's going to select every segment in all of the solids, which is not what you want. At least I don't think it's what you want. So what you want to do is go to by part, propagate, and you're just going to make this like bigger, so like 45. So this is an angle of propagation. So to explain this, you have this edge here between these elements. There's a 90-degree angle. So if you have this angle set at 75, it's not going to cross that. But if you could set this angle at like 100, it would actually cross over this edge. So that's what this tool is doing. So if you leave it at 45, click it, it's only going to select the surface of the ball. And then you can hit apply. All right, so now we can actually set up the contacts. So we're going to go automatic surface to surface. So we can just label them. So contact 1, let's just call it ball to I keep calling it cube, block. And then so off the top of my head right now, I'm not sure which way is correct in terms of order, but I'm gonna say that the smaller surface is the master. So the surface with the smaller elements, I believe that's going to be the master, and the side with the bigger elements is going to be the master, and the side with the smaller elements is going to be slave. So we're going to make this one the slave side. So you're going to hit this button, and you're going to find block top and hit done, and then you're going to hit here to the master, and you're going to make this, wait, I had that backwards. Block top is going to be the master, and the ball is going to be the slave. Just comment if you're confused, because I'm sure I'm confusing everybody. So these are the types. We want this to be segment set, which is what we're on, so 0, segment set. If you wanted to just do parts, you could make this, you can make both these 3, and you could just give these the ID of the ball and of the cube, but we have segment sets. There's also a lot of options down here that we're going to adjust later, but for now, just leave it like this. And then these two are friction, so static friction and dynamic friction. I'm just going to leave them at 0 for now. Yeah, and then accept. And then we're going to do one more. So this is going to be block to ground. So this is going to be slave is going to be the, I'm going to call the slave the block bottom. And then the master is going to be the plate. And that's it. So then done. Okay. And another thing to keep in mind is SST and MST here. These are thicknesses. Between parts, there's like an inherent thickness, at least between shells and solids, or between shells. Like with that bottom surface, we gave it a thickness of 1. Within a contact, it's going to use the thickness of the part before, but you can override it. So I mean by before, so if you leave these as 0, that's the thickness it's going to use. But if you make these 5, the thickness, like if this ball moves downwards, it's going to stop. And there's going to be like a layer of invisibility here, which is however millimeters thick here, or however much distance thick that you set these. And it's 2 thicknesses. So if it's 2 and 2, it's a total thickness of 4, right? So like if you set these, this is 2 and this is 2, this ball is going to stop like 4 millimeters right above this. And that's a way to just prevent penetrations during the simulation, which may cause instabilities. It can also be a way to like artificially model like a covering or something. It's just know that you can overwrite the thickness here if you want to. So accept, and we're done, And once you set up your model for simulation, you always want to I always go into display to check everything. So let's make everything none. Okay. So let's check the contacts. If you go to general, you click the contact between here and here, here and here. Okay, looks good. Initial velocity, ball's going right, looks good. Set, segment, we look good. All right, so this is good. I'm gonna save it out here. This may be the end of this video. I just don't want to make them gigantic, and like timestamps are nice, but somebody's gonna watch this and be like, I really don't care. So I'm gonna make these 2 different videos, maybe 3 different videos, and keep going through this, maybe like a mega thing, and everybody's gonna love that. So if you want to save your model out, you can go to File, Save As, Save Keyword As, and then let's just go to you save it wherever you're at. So let's call this ball and plate. Okay. Wait, that's not true. Ball and block dot K. So you want to make these dot Ks. They can be dot Ks or dot dynes. Some versions of LS-Dyna may not run a dot K, so you can always just call it dot dyne, but don't worry about that. And then advanced, you can decide what you want to save out. We want to save everything out, and then hit save. So then whenever you go, where is this? So you can open it in a text editor, and you can actually see everything that you've set up. So it's all the same that's in keyword. So you got your contact here between the ball and the block. See, it's like all kind of laid out the exact same. And then part, here's all your different stuff. So in the text editors, LS-Dyna, it goes by 10 digits. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then it looks at the next one. That's how it kind of lays out. Like if this was like this, it's going to get an error because there's no value here. Just a little side note, it's super easy to edit things in this, and I've done it in previous videos too, but just wanted to say something on it. So I'm going to quit jabbering on, and this is the end of this part, but I'll make a second part of the video which will go into running it and then varying some parameters. So thanks for watching, and I'll continue this in the next video.